All right, let's look at an example of a vector proof. All right, let's prove that if a parallelogram ABCD is a rhombus, then its diagonals are perpendicular. All right, so let's do that. So you have a parallelogram ABCD, I should say rhombus, and I'm gonna call vector AB vector V, and the vector AD vector U. Right? Then, so here's the proof. Right, so what we want to do is, in order to establish the perpendicularity, we're going to use the dot product. Since if two vectors are perpendicular, if and only if dot product is 0. So we just have to show that the dot product is actually 0. All right, so let's say vector AC. All right, vector AC is going to look like this. Vector AC. Right? You can get vector AC simply by adding vector V and vector, this is vector, same as vector U, same direction and same length, vector U together. So we can write it as U plus V. So vector U plus vector V is the same thing as vector AC. Right? So using the same idea, if you want to find the vector BD, so vector BD, we can go backward on vector V, so it's negative V, and forward on vector U, so we have that. Right? Then what else is given? Since it is a rhombus, which means that two adjacent sides are congruent, so rhombus gives you that norm of vector u is equal to norm of vector v. They have to be the same length. All right. Then let's take the dot product. All right. Vector AC dotted with vector BD. All right. This gives you same thing as vector u plus vector v times dotted with vector u minus vector v. Right? If you multiply this out, you see that the u times u is a norm of u squared, and the minus u dot v, then plus v dot u, then you have a minus vector v squared. Alright, since dot product is commutative, we know that the u dot v is same thing as v dot u and with a different size, so they cancel out. Right? Then if you want, you can write it as, norm of u squared minus norm of v squared. If you factor it out, you can write it as norm of u plus norm of v quantity times norm of u minus norm of v. We can just factor it out. Right? Then we notice that since norm of u is equal to norm of v, we know that this guy is equal to 0. So 0 times anything is 0, right? Which means that therefore vector AC is perpendicular to vector BD, right? Which is equivalent of saying that these two diagonals are perpendicular to each other, right? So that's that. Right, so this is a vector proof, use of the fact that if the dot product is equal to 0, they are perpendicular. We could establish that the diagonals of a rhombus is always perpendicular. All right, that's it. I hope that this was clear.